Okay, so in this objective, we are going to be finding the square root of variable expressions and to use them to solve equations and problems. So the only difference now is we're going to have irrational roots, however, we're going to have variables with it. And instead of trying to square root a variable by finding what number times itself, we're going to take that exponent and we're going to divide it by 2. Now, technically, if you think about it, you could also get a negative answer. But for these, we're only going to worry about the positive answers. We're not going to worry about writing our answers as the absolute value. So let's look at our first example. It's 196 y to the second power. So again, I need to break down the 196. And this is actually a perfect square. But let's go ahead and do a factor tree. Let's pretend like we didn't know that this is a perfect square. So I'm going to divide 196 by 2 and start my factor process. 196 divided by 2. 2 goes into 19 9 times. And then 2 goes in there 8. So I have 2 times 98. And then I'm going to break it down again. So this, and then I also have the y squared. So the radical 2 I bring down. I'm going to break down the 98 into 2 times 49. Now, if at this point you realize 49 was a perfect square and you made a pair of 2's, you could solve this. However, I'm going to keep going. So I'm going to break the 49 into 7 times 7. Still have the y squared. And then I have my 2 radical 2's. So now I'm going to make my pairs. Now, you could also think of the y's as making them pairs. So let's go ahead and split that one up also. So let's make this y times y.
Ms. Perez, your appointment is here. Macaulay Perez, your appointment is here. Front lobby. Thank you.
Okay, so I make pairs of everything, and everything that I can make a pair of, it comes out of the square root symbol. So a pair of 2's, a 2 will come out. Pair of 7's, a 7 comes out. Pair of y's, a y will come out. So the final answer here is going to be 2 times 7, which is 14, y. Now, an easier way to deal with the variables is just divide the exponent by 2. And then whatever you get after you divide by 2, that's what's outside of the square root symbol. Now, if it's an odd exponent, and I'll show you that in a minute, I'm going to break it apart, and I'm going to leave 1 behind. But let's first do the 36. Now again, if you realize 36 was a perfect square, you could pull a 6 out. And then all you have to do with the x, if you don't want to break it down into 8 little x's, just take the exponent, divide it by 2. And this becomes x to the 4th. Because if you think about it, 6x to the 4th times 6x to the 4th gives you the 36x to the 8th. So the final answer here is 6x to the 4th. Let's try this one. Now, this one is actually a trinomial that turns into a binomial squared. So what we would need to do is factor this, and this turns into m minus 3 times m minus 3 under the radical. And then again, pair of them, so one of them comes out. So you will have to factor the trinomials also. Now the last example has an exponent that's odd. And it also has a whole number that is not a perfect square. Again, 18 is not a perfect square. And also, a to the 3rd power is not an even exponent. But I'm going to go ahead and break down the 18. I can factor that into 2 times 9. Now, the a to the 3rd power, whenever the exponent is an odd number, I'm going to break this apart, and I'm going to make it a squared times a. So what I'm going to do is I'm going to go down 1, and make that exponent even and then multiply it by 1. Because remember, when you multiply variables with exponents, you add their exponents. So a squared times a will give me a to the third power. Now, all of these are still under a radical. So now I'm going to break down the 9. 3 and 3. Now again, if you'd rather break that a to the third power into 3 little a's, you can do that. And then now I'm going to look for pairs. So I have a pair of 3's and a pair of a's. The 2 doesn't have a pair, and neither does that last a. So the pair of 3's, one of them comes out. The pair of a's, one comes out. And then these 2 are left behind. So I would get 3a outside of the square root and 2a still underneath it. So the other way to do it is to break down the 18. And if you want to leave the a squared and the a and not break it into a bunch of little a's, take the even exponent, divide it by 2. So that would become 2 divided by 2 is 1. And then this one stays underneath. Let me do it with maybe a bigger odd exponent. Let's say you have x to the 15th. So what I would do here is break it apart. Instead of writing 15 x's and then make pairs, instead I'm going to make it x to the 14th times x to the 1st. The x to the 14th I can divide by 2 and get x to the 7th and leave the x behind. So when it's odd, you're going to have one of the variables left behind. Now, the other thing in this lesson that is going to be very important later on is solving this equation by using square roots. So we can do this 2 ways. We can either subtract the 64, and now I have 9x squared minus 64 equals 0. This is the difference of 2 squares. We're going back to our factoring chapter now. So now I need to factor this thing. They're both perfect squares, so this would turn into 3x minus 8 and 3x plus 8. It equals 0. Now, the instructions did not say to factor. The instructions said to solve. So now that it's factored, I need to set each one equal to 0 and solve for x. This is one method that you can use to solve. Over here, subtract the 8. 3x equals negative 8. Divide by 3. And x equals 8 over 3. Or x equals negative 8 over 3. So that's one way you can solve. The other way is to work with it how it was given. 9x squared equals 64. Divide by 9. X squared equals 64 over 9. To solve for a square root, to solve for a square, I need to square root both sides. So this ends up giving me x equals, and then I could solve them individually. Do the square root of 64, square root of 9. Now, when you do it this method and you're solving for a variable, you need to include both the positive and the negative answer. So that's how it would give me the same answer as if I factored it. So whenever you see a variable squared equaling a number, you can solve it by square rooting both sides. Let me try another example of that because this is going to be very important to you. So if it's not a perfect square, we're just going to leave it in simplest radical form. So let's try another one. So let's say we have a squared equals 100. We can either move it over. a squared minus 100 equals 0. I could either factor it, a minus 10, a plus 10, and then solve each one by setting each equal to 0. A equals 10, subtract the 10, a equals negative 10. And again, the other method would be to work with it as it's given, square root both sides, and again, you need to keep the plus and minus. The square root of 100 is 10. So the only thing added in here is solving these. Again, you would keep both answers and then also square rooting the variables. So that is 11.5. You have homework on this. However, it's not due till Wednesday. It's 2 through 50 even. You might want to try a few of them after you finish the 11 for homework. And then that way, if you're not understanding, you can ask me tomorrow, because we do have a quiz on this on Wednesday, just before we leave for spring break. So I know the syllabus says it's on Thursday, but again, we do not have class on Thursday. So your quiz is on Wednesday. All right, any questions?